All right, so I would expect your output to look something like this, where you've got this LM underscore spec, and then you pick the linear regression model using linear underscore reg, and then you pipe that to the set underscore engine, and you set that engine equal to LM. And so when you run that LM underscore spec, you end up getting something like this, where you see linear regression model specification, and then computational engine LM. And so it tells you, the output will tell you that you're trying to specify a linear regression model. The part in parentheses will say regression. If we were doing something like a decision tree, this would say classification. And then it tells us what our underlying computational engine is. In this case, it's LM. So now that we've specified our model, the next part is to actually fit the data. And so you can train your model using the fit function. And so you'll notice here I have put the LM underscore spec object as the first argument of the fit function. The second argument is the actual model I'd like to fit. And so in this case, I'm using the auto data set, and my Y variable, or my outcome, is miles per gallon. My X variable is horsepower, and so I'm trying to predict miles per gallon using horsepower. And then of course I set my data equal to auto. And so this is what the output looks like now. It says it's a parsnip model object. It tells me how long it took to fit, and it tells me the actual call. So this is the code that was run behind the scenes. So I was able to just use this fit function, but what actually was run behind the scenes, because of the engine that I set in LM underscore spec, was the LM function with this formula and this data set. And my result is an intercept of 39.9 and the beta coefficient for horsepower of negative 0.1578. Okay, so now we've got another application exercise for you. I want you to go ahead and fit this model. And so run this code in your application exercise RMD file, the same one that you did for the previous question. And then what I want you to do is run the actual LM function. And so in the first case, you're going to run the fit using the Tidymodels format. So that would be using this LM spec that you previously created and using the fit function. And then I want you to try to also run this using the actual LM function and see if you get the same answer. All right, so now let's see how to actually get those predictions out. So now that we've fit this model, we've got this LM underscore fit object. And so that has our model fit in it. We can pipe that to the predict function, and we can get predictions on either new data or the same data. And so in this case, since I'm using the same data set that I originally looked at, well, we'll see what that actually results in. So this uses the predict function. One thing I want to note here is that new data here, the argument for where you plug in the data you want to use has an underscore. And so if you have used R for other things in the past and you've used the predict function, the predict function that you use traditionally with other packages sometimes has a new data call that doesn't have an underscore. So just take note that there is an underscore in this new underscore data parameter. And what this does is it automatically creates a nice data frame where the data frame has the predictions built into it. And so this is what it looks like if I actually bind the columns back to the original auto data set. So what I can do here is I'm taking my LM fit object, so that's my linear model that I just fit, and then I'm going to predict each individual outcome. So I'm going to get predicted values for each of my observations. And then I'm going to bind the columns, and so I'm going to bind the prediction data set that I just generated to my original auto data set so that I end up with one big data set that has the same number of rows as the original auto data set, 392, but now it has one extra column. So instead of having 9 columns, which are the columns of the original data set, we have 10 columns, which with this pred.pred column being the new one, and this is the new predicted values. So I can see here, I've got my miles per gallon, which was my y variable, and then I've got .pred, which is my predicted y variable, or my y hat variable. And so, for example, this first one, the actual miles per gallon was 18, and the predicted miles per gallon using my linear model that used horsepower was 19.4. In my second observation, my actual miles per gallon was 15, and my predicted miles per gallon from my model was 13.9. So not too bad. So what I want you to do now is I want you to edit this code below to add the original data to the predicted data. And so I want you to create a new data frame called mpg_pred, and this is going to have the full auto data set, but then it's also going to have a new column .pred that would include predicted values. So go ahead and do that in your application exercise file, and then knit when you're done. All right, so go ahead and make sure you knit those results, and in the next lecture, we'll talk about what you should be seeing.